Hello everyone, in this video I'm going to be talking through what's called the Chlor-Alkali Industry. Now it's essentially an industry that makes use of the process of electrolysis in order to produce essentially sodium hydroxide, but we also get hydrogen and chlorine gas being made as byproducts which too have their uses. Now this is one of a sequence of videos that I've done all about electrolysis. I've done the basics of electrolysis, I've looked at electroplating, and also how you can predict the products of electrolysis when water's involved. Now that does relate, that latter one, to this particular topic, but I'm going to presume that maybe you've seen those earlier videos. We're going to jump straight in to talk about this particular industry and how it works. Now I want you to imagine that we have here just a container or a beaker. So we've got a beaker or container here, and into that beaker what we're going to have is some sodium chloride solution. I'll just do this as little dots here. Sodium chloride is common salt, so quite easy to get hold of. We're going to imagine that we've got here some NaCl solution, some sodium chloride solution, and that's commonly known as brine. So we've got some sodium chloride solution in this particular beaker. Now what we're going to do is affix two particular electrodes. Now in the videos on electrolysis I've explained where these electrodes come from. We're going to put two electrodes in. We'll just colour them in red here. If you remember, we have electricity flowing through a solution, an ionic solution, ultimately to separate it into separate components. So we're going to say that this one here is our negative electrode and this one here is our positive electrode. So we've got our two electrodes in place. Now, if an electric current is passed through concentrated sodium chloride solution or brine, then what we get is hydrogen gas forming at the negative electrode and chlorine gas forming at the positive one. And we get a solution of sodium hydroxide essentially forming at the bottom. So where I'm just drawing this shaded line here, in blue, we're going to get some sodium hydroxide forming there. We'll put the other things in place. So we said at the positive electrode we're going to get hydrogen gas. So we'll just draw those as green dots. So that's hydrogen gas, and equally on the other side put some little yellow dots in, and that's going to represent our chlorine gas. Now let's think about what's actually going on here. So you might have expected sodium metal to be deposited at the negative electrode, because when you have sodium and chlorine in the solution, if it were just sodium and chlorine, the sodium would have a positive charge on it and the chlorine would have a negative charge on it if we think about the ions. So you'd expect the positively charged ion to move towards the negative electrode. But that doesn't happen because we have water present. The sodium is actually too reactive for this to happen, so instead it's the hydrogen given off instead. If you imagine sodium chloride solution, essentially what we've got is the sodium ion, the chloride ion, but now we've got the ions that are in water, so we'll have H plus ions and OH minus ions too, because remember this is a sodium chloride solution. So you've got four different ions here. Now if the metal one that we're looking at, in which case is sodium here, if that is more reactive than hydrogen. Now this is significantly more reactive than hydrogen. Then it's hydrogen that we produce at the negative electrode. And I do have, as I said, a separate video on how you can work out what products would be from this kind of procedure. So if you imagine the sodium ions stay within that solution, let's deal with the chlorine, the Cl-, because it's a negative ion. That negative ion will move towards the positive electrode. Now at the positive electrode, we lose electrons. Those ions become oxidized. So if we were to do a half equation for that, we're saying that a Cl- ion is going to lose an electron, lose an E-, and it's going to form Cl, pure chlorine gas. But Cl travels as a pair, atoms travel as pairs, so that's Cl2. So we're going to need to balance this equation. So if we've got two Cls there, we're going to need a 2 in front of here, so we're going to need 2 lots of the E- to balance all those charges. But ultimately what we're forming here is chlorine gas at the positive electrode. I said that the H+ in this sense will move up to the negative electrode, so H+ here will move to the negative electrode, and if we do the half equation for that, we'll just do it over to the side here. H+ actually gains electrons. It becomes reduced at the negative electrode. It's going to gain an E-, and it's going to form an H atom. But again, H hydrogen travels as pairs, so that's H2. So if we balance it, we're going to need a 2 in front of here and 2 in front of here. So you can see what we're going to form is pure hydrogen gas. So what we're left with in our beaker is essentially the sodium, the Na+ ions, and the OH- ions. And Na and OH go together to form NaOH, which is why we get this, an NaOH sodium hydroxide solution forming. Now let's think about the uses, why we want to even do this. It's because if we think about it, we're getting 3 products made particularly. And I'll just make a note of these at the bottom. So the reason why we're doing this is to produce 3 particular products. One of them is the hydrogen. Now hydrogen is used as a fuel, and we can also use it to make ammonia. One of the products that we want is chlorine. And chlorine, as you may know, is used to kill bacteria in water, and it's also used to make bleach and plastics. But the third and final, and perhaps most important reason why we do all of this, is to produce sodium hydroxide, NaOH, solution. And sodium hydroxide is used to make soap, it's used to make bleach, ceramics, and even paper. Now, the reason why it's called the Chlor-Alkali Industry is chlor, because essentially we're getting chlorine gas from it, and alkalies because sodium hydroxide is an alkali. Sometimes it's referred to as Chlor-Alkali Industry, but in the context of learning about it just at Key Stage 4 chemistry, which is usually when this topic is taught, if you just understand the principle of this in terms of electrolysis and where the ions are moving to, that should help. So there we have a little bit about using electrolysis to make sodium hydroxide solution. Because we've got a metal involved that is more reactive than hydrogen, it's hydrogen gas that is produced at the negative electrode. And in this case, we get chlorine gas produced at the positive one. Okay, hope all that helps.